Hi, I'm Carolina Bessega. I'm the Chief Product Officer and co-founder at Stradigi AI. I'm really excited about sharing with you the presentation, Small Teams, Big Dreams. How can you get started with AI today? Before starting this talk, let me talk a bit about me and about Stradigi AI. I have a scientific background. I have been working in machine learning for 20 years now in different capacities, from leading a research team at a university to working in applied machine learning services and products in Canada. At Stradigi, we help companies like yours to launch AI in your organization. And the way we have to do it is through our SaaS AutoML platform called Kepler. Today, we will start talking about what has changed in the last few years. That will bring us to the rise of automated machine learning. And after that, we will be covering a fascinating real world example on how these small teams can apply machine learning right now. So from there, we will highlight some practical tips from generating value today. And finally, we will be concluding with some key takeaways. So what has changed? And this is not your typical like AI history diagram. You know, it usually starts in 1945 with Alain Turing. I wanted to do something different. I want to actually talk about the last 10 years only to highlight the speed and importance of AI contributions made and try to give some light on where I think that we are going now from the business perspective. Around 10 years ago, AI started going like mainstream in the research community. That was helped by the improvements in hardware, in data. So now deep neural networks began to show capabilities. And after a couple of years, actually, they even surpassed human capabilities in some cases. So around, I think it was around 2015, every company was hearing about AI. And the hype started. Everybody wanted AI now in their company. But that wasn't that easy. So a couple of years passed, and around 2017, in my opinion, that became the POC era. Like large research projects, that was the norm. You need a research team, you need a group of PhDs if you want to do AI, because this is something very complex, and actually the algorithms are complex, and the data is complex, and the programming is complex. And basically having a science PhD, this was never better paid. This was like great for scientists. And but by 2018, people start to realize that there were some pieces there like missing. And it was common to hear that 85% of the AI projects never arrived to realization. And this research and these big teams with machine learning operations and machine learning engineers were very expensive and mainly only affordable by big corporations. So quickly, because the market adapted to everything, 2018, 2019, a lot of tools to increase the efficiency of data scientists started becoming more popular. And the automated machine learning frameworks and machine learning operations tools, MLOps tools, start their race to win the market. So now we are in 2021 and beyond, and science continues evolving and has evolved to the point where actually there are specific tasks that can be automated to the point where business analysts, inventory planners, business intelligence teams, marketing analysts, all these people who actually work with data in their day-to-day, but doesn't have the machine learning knowledge, they can start leveraging AI tools in their day-to-day by using these automated machine learning platforms explicitly created for non-machine learning experts. We have been hearing about no-code, low-code platforms. So what is AutoML for business, and what can it do? So here you have your typical data science flow, and probably all of you know how this goes because you're all here. So I imagine you have already tried to launch data science projects in your organization, but usually starts with a person who wants to solve a problem. And usually this is either an optimization, or is an automation, or is a business process understanding. And this person talks with a data scientist, and maybe there are some data engineers also involved, can be internal, can be external. And after multiple iterations that often last for weeks or even months, they can break down the problem. They can prepare all the required data. They have built models. They have optimized models. Now, the next step is to prepare a report or a dashboard to start discussions with multiple stakeholders. These discussions involve also additional information and multiple iterations that can happen. So all these two steps process you have here is what we usually will call in creating this proof of concept, and it might actually take months, maybe depends on your project, maybe 3 months, 6 months, 9 months. So, and these are really bottlenecks for an organization because only the communication between the different stakeholders makes things slower and slower than what it should. So the third step, if we pass the first two, is that now this model can actually not go to production in the way it was coded. So now we need to make sure that the model is reliable, that it can be implemented in an end-to-end life cycle, that has all the software development good standards that we need. And finally, you usually need to integrate this model in your current tools, either a website or a CRM, so business users or any other consumer can get the benefits of the model. So as you see, this is long. This requires multiple stakeholders and requires multiple back and forth cycles. And this is where AutoML came to the picture. So, and I'm going to explain you how it came first. So there are certain steps that we can actually make automatic. Which ones from all these steps you have seen, which ones will depend on the tool. There are different tools in the market, and depends on who is the final user of the tool, it might put more emphasis on one thing or another. When it's an AutoML tool for business users, you actually need to make the full end-to-end cycle automated while keeping, and this is very important, while keeping a human in the loop to make sure the business context is considered in the proposed solution. So this is the characteristic that the AutoML tool will actually make all this process very smooth. It's going to go from helping in the data preparation to deploying the model, while keeping the business user in the loop, not to ask machine learning questions, but to ask questions related with their business context. So, and what can be automated? What are the type of tasks that can be automated? And I'm going to make a point here. The capabilities I'm going to be talking now, and in fact, what was achieved in the real example, are all based on our experience with our own platform, Kepler. So let us start talking a little bit about these tasks that can be achieved. The first thing is data classification. So you, for example, you want to create a model that learns to classify users as churners or not churners. Or maybe your data entry is a customer reviews, and you actually, what you want is to classify customer reviews according to the emotions. Is an angry user, is a happy user. Maybe what you want is to classify images. Imagine you are in manufacturing and you have a pipeline where you need to do visual inspection of your products. So in that case, you might want to have a model that is able to classify images in the damaged or ready to ship. Additional to classifying, there are other tasks that we actually can automate. For example, I can predict a quantity based on knowledge, based on other variables. For example, a real estate agent might want to create a model able to predict the right price for a property in the current market, in the market today. Or maybe somebody in an inventory planner who wants to predict a forecast lead time or forecast demand on a certain SKU or product. There are other tasks that we can still do. For example, we can detect outliers, or we can find patterns and segment things into groups that are found organically by the system. But in all these examples, what they have in common is that even if there is not a unique solution to them, it's not that like there is one algorithm that will work well for every classification. But what is true is that the science has advanced to a point where the machine can actually choose the right algorithm for you, for your data, for your case. And not only the algorithm, all the steps in the process. So now that we understand that things can go faster, and we understand that there are tools that are able to do automated machine learning and automate the full flow for business users, now I want to drive through, this is a real world example. It is based on an actual client, and I have hidden some details for privacy reasons, but the critical point that I want to make here, it remains. So this is a company in the online reviews, peer review reputation. It's a website that serves both businesses and consumers. These consumers will write reviews about products and services, and the businesses will address their concerns and get insightful feedback at the same time. So you have the consumers and the businesses. This is a mid-sized company with about 200 people. The team that has had access to the tool that is conformed by two persons. We're going to call them, one is D. D is a project manager, and he works in the software development team. He's passionate about automation, find ways to give more value to the customers. And we have V. V is a product manager, and he's in charge of business intelligence. And he's the one who sets and monitors all the KPIs in the business. And he wants actually to understand what drives performance. That's his goal. Both of them has a great understanding on their business, and they have a big drive. They want to excel and surpass any competitor. So let's see. In about a year, they actually finished 5 different projects. V actually, he only has been working for 2 months with the platform. Most of the projects were done by D. Both have other responsibilities in the business because it's a smaller organization with a lot of different aspects to cover. But how did they start? So the first motivation they had was to increase customer satisfaction. And this is why they start with the customer side. But as they were understanding better what are the capabilities of the Automel platform, they thought, okay, we can expand these projects to also other business areas. And I'm going to go in detail a little bit on 3 of these projects. The first one that I want to discuss is the user intent detection. And this is super interesting. So they knew the users go to their site, their consumer. I'm talking about the consumer. The consumer go to the site with 3 primary intentions. It's either to write a review, either to read answers to other people's reviews, or to read reviews to decide whether to buy that particular product or go to that particular store or not. So knowing the user intention when he lands to the site actually was something very, very desired by them, because that would allow them to monetize and also engage better their users. So they also knew that this is a complex problem because, you know, this is not a property that is associated with one user. So I can go to that site to write a review today, but tomorrow I can go to read an answer, or I can go because I want to buy another product and I want to know what's the opinion on that. So how can I actually understand the intention after I enter to the site and after maybe a couple of clicks that I do in the site? The other thing is that most of the users, at the moment that they land into the site, they are actually not logged in. So that makes things even more complicated, because sometimes if they clean cookies or things like that, they don't have a lot of information about what this user was doing before. Well, they actually created a model. So it's a classification model. They wanted to classify the users in these 3 groups according to this intention. And the data that they used, they had in their analytics platform, they had the information about all the clicks that are made in different sessions. So they create a data set where you had the first 3 clicks in every session, and what was the last the last activity that they did. So to understand what is the intention. And they created a model that was 86% accurate. They only took 2 to 3 weeks to actually create this model. And after that, they were able to integrate that into their website, make the website react to the prediction in real time. And they currently do around 90,000 calls to get predictions on user sessions every day. So that was a very happy path and a very good story. So after that, the next step was, again, with his passion of automation, he said, okay, if I also can do classification, he understood already classification. If I can do classification, but now with text, I have so many customer reviews in here that need to be classified. They need to put that according to the topic. And they had an internal solution that they have created, but was too slow. The latency was too high. So they decided to take the reviews that they had with the classification that was done either by their other solution or by humans, and they put that into Kepler, into the platform, and in only 2 days, they got a model, and they were able to use the API and have a latency of milliseconds. So they and not only that, the new model was 9% more accurate than what they had before. So look at this. We're talking about a non-machine learning expert that in 2 days, yes, he had the data. That's an important point. But having the data, in 2 days, he was able to have the model productized, have the model in an API, being able to deploy the API, get milliseconds accuracy and latency, and improve the accuracy. So this is pretty impressive. But now, at this point, I'm going to talk now about the actual revelation here. At this point, V was our product manager, and he was aware of the success of D because they were working closely together. So, but he was facing a challenge and in his own job, and he needed answers. So, and this is where I really think things became impressive. So what was the problem that V had? He was mentioning a KPI in their business, and that KPI has dropped 10% from 1 month to the next month. No clear explanation. Nobody knows what's going on here. He needs to know what's going on. So he's a business person. He's not a programmer. He's not a data scientist. He has no machine learning experience, but he has been exposed to all these discussions with V. So he thought by himself, okay, give me that tool. I'm going to take that platform, and now I'm going to try to put all my data there. I'm going to do a predictive model to see if I can understand this behavior. And if I actually can, using the model interpretability and the feature impact, if I can understand what are the key factors that are affecting this value. And he was able to get a pretty accurate model. He was able to find where was the difference between 1 month and the next month. And he discovered that, in fact, this is super interesting, that there was a variable that they were always collecting, but they were not paying a lot of attention because that variable was always kind of stable. But at the moment that that variable passes certain threshold, what is happening is that the KPI they were actually interested drops. So now this helps V to actually have a better business understanding. He set this variable as a new KPI that he's monitoring, and he's making sure he had initiatives in his business to ensure that that variable never change again. So this is pretty impressive, and this is a window to the future. This is a window of what we expect that will happen when these tools can be in the hands of business users. So since that, the company has onboarded other 4 users, and they continue improving with these projects daily. They have ideas, they put that in the platform, they iterate, they get some insights, they use that in their business. So what's the formula? The formula for value generation, what it is? The first thing is ask the right question. Start simple. So if you have a big problem that you want to solve, don't try to solve all the problems at once. Think, can I break down this in simpler sub-problems? Can I break down this? Oh, I have a problem. I don't know. My inventory planning is being messy, but I have that involves the orderly time and involves the demand forecasting and maybe involve other processes. Can I actually create a model for one item at a time? So go one step forward every time. So the second thing is think about your data. What data do you need? And every time somebody asks me that, my answer is always think like a human expert. What information would you use if you as a human, you need to answer this question? In your expert knowledge, what are the factors that might be influencing your answer? After that, think, what data do we have? And try to find what is the match between both of them. And start, if you have some data, even if it's incomplete, you can start iterating. You can start saying, okay, let me see where this data allows me to go. And after that, say, okay, you know, these are the 3 factors more important. Start collecting more data, including the data, and increase your accuracy as we go. The next step I think is important is to have the right tool. It need to be a machine learning tool for business users, not for data scientists, because you're not a data scientist if you are in this capacity. And there is something that and now I have my scientific hat on me, is very important. So this tool needs to help you understand when you can put a model into production. It's not only about accuracy. There are multiple other things. For example, is my data in production going to be similar to my training data, or is it going to model to fail? Or is there any bias in my data? Is there any leakage in my data? So these are concepts that probably you don't manage. So you need to make sure that as part of the automation, this tool actually has these guardrails, and you can trust. You can trust in these insights, and you can trust that when you put this into production, you are going to be served in the right way. And remember, start simple, iterate, and improve. So my last slide is the key takeaways. So I only want to say 3 things. First is for specific standard tasks, like classification, prediction, segmentation, the best people to get predictive and prescriptive insights from the data are the domain experts. You need, a person who doesn't know anything about supply chain, it's very difficult for that person create a model about supply chain because there is key information that is required. The second thing is that these tools, actually they can augment the human capacity in your day-to-day. Actually, the idea of these tools is to help you to do a better job. And for sure, the key factors are the data, that is always important, the tool, and more than ever is important, the right team. And the right team is not only in the expert knowledge in the field, the ability to understand your data, but also in being eager to do something that goes beyond the normal things that you do. You actually want to excel, you want to be the best. So that's what it takes. Thank you very much. It was a pleasure. I hope that you found this insightful.